All right, we're on the last example for this section. This one's actually a pretty short one. Now, what we're doing here is we're still talking about how to be able to get like bases and all that, or how to be able to solve with unlike bases. But this time we're going to do it by graphing, because remember, whenever we have any kind of equation or function, if both sides represent a function, we can plug them in as separate functions into a graphing calculator, and where they meet is the value of x we're looking for. It's the one value that solves x. So in this case, we have a function of 1/2 to the power of x minus 1 equals 7. Now we could go through and look for like bases, and we're not going to find them. We can't. There's no way we're going to get a base of 2 on both sides or a base of 7 on both sides. So we got a problem. But we can actually bypass the problem. Now, if you're using a graphing calculator like the TI-84, the Plus, the 83 even, something like this, it's going to work a little bit different. I'm going to go over on Desmos, but we will go over, and because we don't have as many in class, try to remind me, if we haven't already, to make sure you have the app for the 84 on your calculator. There is one, or at least to get it to act like an 84. Now, with that said, what we've got here is we're going to set, okay, want to color coordinate. We want to set y1, because when you use this and you go into graph, first you do y equals on this side, then you're going to hit graph to actually see the graph. When you go into y equals, you can enter multiple functions at a time. So there's y1, y2, y3, y4, y5, y6. I think it goes up to 10. This one is going to be set to y2. Now what I've done is I've set that up in Desmos here already. If you look, the equation in red is the y equals 1/2 to the x minus 1. So the red graph is our first function, or the y1 we were going to enter. And y equals 7 is the blue line. And what we find out, if I just click, you should be able to click on the point, and it indicates by a gray dot, at least on my version, that the point where they meet is negative 1.807, 7. So what we're going to be focusing on, it took it away. Nope, I want that back. All right, so what we're going to be focusing on is that negative 1.807. So we found that the point was negative 1.807, 7. So what that means is at 7, x was this. So this is our coordinate. Now, I don't want to say that's my final answer. That's a little bit long. 2 decimal places is just fine. So this 7 tells the 0 to grow up, and it becomes negative 1.817, and that one's going to be my final answer. Now, on B, I'm going to actually type it in this time so you can see how I did it and why there was actually parentheses around the exponent, whereas now, how it's written, there isn't parentheses. The parentheses was around the base. So I'm going to be looking at the book because it has the actual problem. I'm going to come over here and I'm going to delete both of these. Now I'm going to go to enter, and I don't know how much it's going to show on the screen because I never noticed, but I want to type y equals, and I get 3 to the, where are you? I don't want it to be squared, but that's the only way I know to square. So to bring that up, and I want to do parentheses, because watch this if I don't. X plus 2. Notice how that is not what I had originally. That plus 2 should be up with the exponent of x. So what I'm actually going to do is I'm going to put parentheses x plus 2 And look what happens. It stays in the exponent where it's supposed to be. And notice how the graph did change. Okay. So I'm going to come up here. I'm going to hit enter. Then I need to enter my other function, which is just x plus 1. I'm going to hit enter. And now I'm going to look for where they meet. We run into a problem here. And some people would be like, I must have done something wrong. But we didn't. We entered in exactly what it's supposed to be. It must be those parentheses, right? No, those parentheses were needed to keep that plus 2 in the exponent where it was to begin with. So there's actually not anything wrong. What we're looking for is where do these graphs meet? And the answer is they don't. So since they never meet, so there's no solution. And we did this by setting 3 to the power of x plus 2 into my first y, and x plus 1 into my second y, are setting two different functions graphed differently and looking to see where they met. Since they didn't meet, there's no solution. The first one we did by placing the base of 1/2 to the power of x minus 1 as one function, graphed it. Then we entered the other function of y equals 7 as a second function. We looked to where they meet, which was negative 1.807 comma 7. And since they met at 7, I use this, because at 7, when y equals 7, x was this. Our answer actually is x equals negative 1.81. And I should have put that as a better, more accurate answer.